Where's the button to get going? Boom, boom, boom. Dun, dun, dun. Hello and welcome to Practicalli with me, John Stevenson, with very messy hair today. I hope you are all safe and well. Let's hide my messy house as well. Today we're going to cover some more of the Brave Clojure book, which the book was written quite a while ago, but all the Clojure code and Clojure examples are still very good. Clojure hasn't changed much in the last 5 years in terms of the core. It's like developed massively in terms of the community and or the tooling, and a big shout out to Borkdude and Pez and Side and Bozdar for doing amazing work in all the tooling, and everybody else has been driving the community around there as well. Too many names. If I mentioned all the names, that's just the entire hour taken up. Thank you very much for joining me as well. So let's get on with today. Just a quick, if you haven't watched one of these videos before, let me just check all my buttons are working. There we go. Whee. So you can spot me via the usual channels. Just want a big shout out. I've got quite a few sponsors this last few weeks, so thank you very much for those that keep me going. Supports me on all the work I do at the weekend to get these broadcasts and books up to date and useful. And if you want to reach out to me via the channels, during the videos or afterwards, then feel free to come and ask me some questions on these. My preference is Zulip, but I am monitoring all of these channels as well. There's the books. Keep on doing little bits to the books. Just added VSpace code for those people who love Vim. For those people who love Vim and want to use Carver with Vim, then I've added that to the Clojure aware editors. And so you can go in and it's not too difficult an install guide. It's fairly straightforward. Just install Carver and so on. Hello everybody who's joining. And there's a little pull request. There's one extra step to do it, but it's very simple, copy and paste. And so you can have VSpace code, which gives you a nice space max view. So you can just type space and you get the menu at the top there. And I've just added the key binding so you can drive, I think, all of the common functions in Carver. There might be a few ones missing, but let me know. But you can also use Carver without Vim as well if you really wanted to. Okay, thank you very much for joining. Let's get on with today. This is very much unscripted and very live, so feel free to ask questions, suggest corrections or alternatives as well. So we're going to have a quick look at the Brave Clojure for the Brave and the True, or Brave Clojure for short. And you can go in here and just get the free book, or you can buy the book if you really like it. If you like to have something tangible in your hands when you're reading, then you can do that as well. Or you can just go to this link I've posted in the chat to access the freely available version. And we're going to look at, we looked at 1 and 2 in the last video last week, I think. Seems so long ago already. And this one we're going to look at actually doing things. How do we do things in Clojure? So skip some of the blah, blah, blah. So yeah, it starts by talking about forms. I think this is a quite useful thing to understand. So there's a lot of kind of terminology to kind of get up to speed with Clojure. So forms is basically can be a literal representation of a data structure. So form is something simple like one or a string or a collection or like a sequence of values. So this to me, I consider, although this is like lots of string values, it's in this case in a vector data structure because of the square brackets. So that's the whole vector is considered a value for me, just like a string is, and like numbers and so on, and characters. But you can obviously do more interesting things. You can like iterate over a vector, a sequence, and the other data structures. Although you can actually iterate over a string as well. But that's because a string is essentially can be treated as a sequence of characters. Excuse me. Okay, and then it also talks forms about, it says operations here, so if you're coming from other languages you might be used to operations or methods, but Clojure is a functional programming language, so we have functions. And what is a function? Well, a function is a list where the first thing in the list is taken as a function call and the rest of the things are taken as arguments. So here it's calling, so in some languages you'd have like an operator, so plus would be an operator, but in Clojure then the plus is actually a function. There is a defn somewhere in Clojure core that defines the behavior of plus, and it can take multiple arguments. So this is quite unique, I think. Certainly if you compare it to Haskell, Haskell has functions that takes a single argument and then of a type and then returns another type. That argument could be quite complex. It could be a complex collection or complex sequence, but I think Haskell typically takes a single argument, whereas Clojure is a bit more pragmatic. You can stick as many arguments in there as you want. And so here we've got like string, calling a string function to join several arguments which are all strings. Oh, there we go. So that's fairly simple. So a form or an expression, kind of like if you just have an open bracket, then that's not going to be good. So when you're in your editor, then hopefully your editor will add the closing brackets for you, so you don't get incorrect expressions, incorrect forms of code. Did I got my? There we go. So if we just look in here, this is just a simple project I just created earlier on. So we've got source and Practicalli. Let's look at that. So yeah, so here we've got some functions. So we can just do, so when I'm pressing the open key, then open parens key, it's creating a close parens for me. So that's by the magic of something called smart parens. There's also paredit and parinfo that help do that as well. Where's the plus key? There we go. So you can do plus 1, 2, 3, 4, and as many, and you can also chuck in here a function range. 1, 2. Oh no, let's range do that 5 to 10. There we go. I'm not running my REPL, that's why it doesn't work. Let's run the REPL. So I'm just running a REPL process, and then that's going to connect to my editor automatically. So then as I'm writing code, I can just evaluate it as we go along. There we go. Oops. There we go. Okay, right, yes. So that doesn't quite work because I'm passing in a sequence here rather than an actual number. So yeah. So the kind of, if we look at the syntax of the arguments, then we're passing in individual. So down here at the bottom, we're passing in individual arguments, where here we're passing in a collection of range. So we want to do, so we need to apply plus to that. Let's take that out. Nope, what am I doing? Oop. So sometimes we need to do techniques like applying a function like plus over that, and we get the answer, and that one should give an answer 2. There we go. So we'll have a look at apply a little bit later on. That's a little bit more advanced. Yeah. Oh, concat. Yes, bit of concat. Nice. Yes, that's quite good. Yeah, so if we did want to have that all in one expression, oops, wrong. Then we can do as Chris kindly suggested. Boom. We join those two together, and I missed. Which one did I miss? Copying and pasting is not advisable always. Oh, we got a missing thing at the end. All right, there we go. That's happy now. Yeah, if you copy and paste, then you don't get the protection of Power Edit or Smart Parens to help you. But yeah, there we go. So we're basically taking these values and concatenating them with these values, and then we could apply it. So we're basically using concat to create a single sequence and join them together. But we've already gone way past the introduction part of the chapter we were doing. But let's. But yeah, so the trick to kind of learning functions is to use the Clojure docs or the doc strings of the functions. So if you want to do Clojure plus, I'm not sure how to search for that actually. There we go. Oh, that's not it. Clojure docs. There we go. There we go. Oh, plus. Yeah, so in clojuredocs.org, there's a huge amount of Clojure core functions. And you can just go in here and search for whatever function you want. So map is quite a common one. And it tells you what the different arguments are, what shape of arguments you can pass to that function to make it work. And the really nice thing about this website, it also gives you examples as well. Some editors will also allow you to just pull directly from this website within the editor, so that makes it nice and simple to get those examples. Let's close that. And yes, so it's mentioning the so you might be in most other languages you kind of have this infix thing, so you're actually putting the operation, the function, in between the values, whereas what Clojure is doing is he's making it very clear and very simple actually how you structure your code. The first thing is always the function, and then you can pass in all the arguments. So it also makes it like less typing as well, because you don't have to type the the operator in each all the time. And it also makes it more deterministic as well, because you don't have to remember operator precedence rules. If you do a search for JavaScript operator precedence, and you go to the Mozilla one, then there's just lots and lots and lots and lots of things. These are all the things you kind of have to remember when you're using operators. I'm not picking on JavaScript particularly, but it is an example of it's just adding more cognitive load to the syntax of the language. Whereas Clojure, as long as you remember to press the open parens, open bracket, you're probably safe. And then it's just combining and nesting parens just to form the right shape of your code. I do have some examples in here. So if you go to the Practicalli Clojure book, there's kind of like a similar kind of introduction, probably a little bit less, a little bit more terse than the Brave Clojure book. So if you go here, you go to this website, then this has actually got a built-in REPL, so you don't even need to have a REPL running. And so here we've got, we're adding some numbers. Let's blub that out of the way. There we go. And we can see we can Oops. If we don't have the closing bracket, then we get an error in the code straight away. But we could have as many of these numbers as we want. And the nice thing about this REPL, which is something called clips, is it's giving us the answers as we're typing as well. So it's giving us a really fast feedback. Oops, what's it doing? And so you can have kind of nested forms, nested expressions within an expression. And it may look a bit more complex at first, but actually it's actually giving you a very deterministic way of understanding what it's doing, because this minus is associated with these two values and these two values alone, not with any other values. And so you know the order in which to evaluate these things, because you have to evaluate 7 minus 2 first before you multiply that answer with 2 and 4. And so again, you don't need to know any other syntax. You just need to know that the first thing is the function you're calling, and everything else is an argument. So in here, 3 is the first argument, and this expression. So my mouse is not. There we go. And this expression here is the second argument to plus. And so we have to go then work out what this function is, and this function, and then this function. We call those, evaluate those in turn, and then we get that result and put it into the second argument. Firefox is going a bit funny with their selections today. We put that in the REPL there. So basically, when we come to, if we want to read this ourselves, I mean, we can put this into the REPL and just evaluate it, and we get an answer. We can come in here and go in and evaluate. And I've got a thing that will evaluate and replace the value. So this is essentially how we're doing it. So we go in and evaluate that value, and then we can evaluate this expression, and we get another value. And we can do the same thing with this expression as well. We get another value. So we can kind of break down, and that's a way I usually, I think that was a useful technique I found when I was learning Clojure, is to kind of take in the individual expressions where possible and see what they do, and then you can kind of combine the whole expression and see the result as well. So if you're not sure what something's doing, then just pull it apart slowly and see what the individual parts do. And then it's a lot easier to understand the whole thing, especially when there's a quite nested kind of expression. If we look at, for example, let's see, for Clojure. If I've got that, that's not right. Can't type, sorry. There's my for Clojure. There we go. Yes. 53. You can get really long expressions in Clojure, but there's often usually a way to refine them as well. So if you get something this long, then obviously pulling certain parts apart make it a lot easier. But then I actually just refactored this down to something a lot simpler in the end. I think. Boom. Yeah, so I pull it down to this. So you can take, so often when you're learning Clojure, especially doing recursion, you'll kind of find like looping and so on quite verbose, but you can actually usually just, but they kind of, looping does tend to be easier to follow, especially if you're used to iterative programming, but then you can kind of learn the Clojure core and start to reduce it down a lot easier. But even then, you might not understand a particular expression, and you can kind of pull it out and put in the value that would normally be there, and then see what that does, and play around with it. And that's a good way to kind of diagnose and understand what existing code does. Okay, let's go back to the book. That's not the book. That's the book. Control flow. There is an if. We do have an if. Is there any questions? No questions. We got to. So if something is true, then do the next thing. If it's not true, do the thing afterwards. So if this Boolean kind of expression, Boolean form is true, then we would do then. And then we've got, it is an optional else. So then let's see, let's go to, do I have any examples here? Or let me just check. I do not have one. Okay, let's go to the editor. We've got if, and then what is it? So if greater than 1, the value of 5, then we print out true or false. Why is that not working? Oh, I haven't. Am I? Oh, I'm sorry. I'm in the wrong. Whoopsie! I'm in the wrong project. There we go. There's my project where I'm running a REPL. There we go. Yeah. So. Oh, yeah. It's less greater than. So if 1's greater than 5, if we swap those over. I always get those the wrong way around. There we go. Then it's true. So 5 is greater than 1. So yeah, I think the way to remember it is like pointing down. So if this first value is bigger than the next value, then it's true. But we can also get rid of the false. This is still legal. Still compiles. If we swap these around again, oops, sorry. Then it's returning null because we haven't actually defined anything afterwards. It's still perfectly legal code. It's not going to fail because you don't put an else statement in. But if you are going to do this approach, then Clojure idiom suggests, and in fact I think my CLJ condo is suggesting, if I hover over there, oh, it's missing else branch. Oh, I would have thought it would tell me to use a when. Okay, so that's nil, and if we swap them around again, then it's true. So if you've only got one branch, then usually else is a preferred approach, more idiomatic as they call it. Idiomatic just means that it's the preferred way of writing Clojure. Clojure is a general purpose language, so you can kind of write it in any way you like. You can write it in a less than functional way if you really try. But there is a kind of a particular idioms that we can that you learn as you pick up Clojure. Okay, let's go back to the Brave Clojure. Are we feeling brave today? That kind of covers that. So there's got some examples there. Yeah. We've done that. So obviously this form, this expression that we include in the f can be as kind of convoluted or complex as you like. It can be pretty much any expression. It could be an external function that you use. There's lots of predicate functions in Clojure as well. So we go up to the top here. I believe I created a list of predicate functions at some point. Predicate functions, there we go. There's a nice long list of predicate functions. So you get things like, is something a Boolean? Does it contain distinct? Is it empty? False, and so on. False and true, identical. And so all these, you can see, all of these have got a little question mark on. That's just a convention to show that the expected kind of argument is going to be a Boolean. It's going to be a value that's true or false. And so you can have a value of true. True is a legal value in there, so we can evaluate that, and straight enough true is true, false is false. And then we can also do true predicate. So a predicate is just a function, because here we're just using it as a function call, and we can pass in true into here. So here we're using just the literal values, or literal Boolean values of true and false. Literal just means we're just expressing those values very specifically in their basic form. And true, here we're calling that function with the argument true, and we get back true. If this was false, oops, I don't want to do that. Then we get false. What about nil? Nil is an interesting one. That's also false. What about 1? That's false when we pass it the predicate, but usually values are kind of considered as true. So the only things that are really false are, we do false in here, false. False is false, so that's true. Nil, that's false. What about 1? I've never actually tried that. Oh, that's false as well. But if we use a if 1, 2, yeah, so we can actually use values in a conditional. So they're not kind of, those values are not true or false when we use it with the predicate. So we get, oh yeah, no, that's true as well when we do false. But it's not true, but it can be not false. That's a little bit confusing. Probably a better way to explain it in a later broadcast. But essentially, we can use a value. So if we use nil here, if we use false here, sorry, then obviously that's giving a nil answer, or we can do let's make that false. There we go. And if we do nil here, then that's also false. If we do 1, then we get true. So there's this idea of falsy. So nil is falsy. So like when we're using that in a conditional, like if and when, then so nil is going to be considered false. So you pass nil rather than doing things like programming tricks like -1 to identify something is like a negative result, which you usually get on command lines and some programming languages that don't have a true and false or we can actually use nil to represent false. And when you call functions, that's handy, because when you're calling functions that actually return a value, which all functions do return a value, that's an important thing to understand. You always get a value back. Here we're doing if false. It's not going to match on the true, so it's going to return the value nil, and the value nil is a perfectly legal value in Clojure, and so we can use that as a conditional that becomes falsy. But if we have a value that, if we're returning say 1 for example, then, or a sequence, so if we have, I think this should work, There we go. So if you got some actual value that isn't nil, then that's going to be considered true. And so this is the basis of rather than use this is like an idiom. So if you've got a collection, a simple sequence, then we can use the empty predicates if we wanted to. Slurp. There we go. And that's it says it's false because it's not empty. And then to get the inverse of that, let's wrap that. We can do a not. And so we can kind of put that in a test because we want to do something when something's not empty. But instead of doing that, there's a simple idiomatic way of doing that, and that's using all fingers and thumbs now. And that's using seek. 1, 2, 3. Sorry. And so that's returning a value. So therefore that is truthy. If seek returns a nil, like seek, does the empty? I think the empty one must return. Yeah. So the empty, an empty sequence, an empty vector is returning nil when we run it seek, when we give it to seek. So that's producing a falsy answer. So we can use these in our if statements. Well, then this video is becoming more about conditionals at the moment. There we go. But this is useful to kind of know. It's like a foundation block to understand. So so the seek is empty, so we're getting false as a result. And if the seek had values in, if the collection or the sequence have values, then we get true. So rather than using not and then empty, the more idiomatic approach is to just kind of test if it's a seek, and then it's a more efficient way of doing that. It's possibly slightly less readable when you first start working with Clojure, but it's an idiom that very quickly becomes commonplace and common to your mind because it's used quite a lot there. If true, true, is that right? If yeah, okay, true. Does that work? That's the comment in the comments. Yeah, so this is a value. So a seek, a vector is still a value, and it's not until we actually test it with seek that we can then find out that this is false. So you actually have to test the value. If you just give the value to something, then the conditional treats it as a value like 1. So yeah, so like if 1 true, that's true, and we do the same thing for a sequence, an empty sequence even. So we're not actually testing whether any kind of properties are about this sequence. We're just saying, well, is a sequence, is a vector as a value true or false? And when we give it to a conditional, it's true. Whereas with the seek or with the not empty, we're actually testing to see whether the contents of that sequence is true or false. So we're actually testing to see whether that contents of the sequence of the vector has any values. Whereas here we're testing the value of that sequence itself. So it's a subtle difference that hopefully makes sense. And hello, Ricardo. And hello, everybody who's joined. So hopefully that gives some examples. I think that is a section that I will kind of add to the book in a bit more example as well, because I think it's quite useful to actually drill down on this. But the essential basics of using a conditional when you're first starting, you've got if and you've got when. And so if you've got two branches, if you've got a true and a false branch, use if. If you only got a single, if you just want it to happen when it goes true, then you just use when. And if you're testing to see if something's empty, you can use not empty. But if you're working with other people, then they may suggest using seek at some point when they look at your code. Nothing wrong with doing this initially, but I guess when you're working professionally, working with teams, then they'll probably encourage you to use seek more often. Okay, we've got 12 people on. Thank you very much for joining. Let's see, that's a lot of conditional stuff. There's also, while we're talking about conditionals, there's also or and that are really, really useful. So this will do if there's one or more things. If any of them are true, then we'll return true. And if all of them are true, then we get true. If only one of them are true, or if one of them's false, then we get false. One of the interesting uses of OR is, like, for example, if you're building a web application, if you've got a value for like port value, and that's not being defined in your environment, then you can kind of set a default value for the port for your application to listen on. That's a very simple kind of example of port. And you could have like a series of conditionals that you want to make sure that all those things are true, and then you'll do something. I wonder if the book's got, I'm not sure if the book covers those or not. Let's have a look. There we go. Somebody asked me a question about fits table. I do not know what fits table is, but I don't know. That's an interesting one. That's a new one on me. I'll have a look now. I might cover that in another one. I basically suggest you go to Clojure and then fits table. Fits. No, I didn't like the look of that. Was I get that right? Yeah. Oh, that no, don't know. I may have spelled that wrong. I'll have a look at that and put some discussion in the chat. Okay, sorry about that. I'll try and find out later. So we've covered if. So it's also going underneath. Oh yeah, that's one important thing we didn't cover. So when you're doing if, because it's if is actually a macro, which is a function that kind of does some things underneath before it actually runs. We'll cover macros later on. There is a chapter on this towards the end of the book. And if is a macro because we're kind of treating, this is essentially like a third argument here. So we've got if, false, and then we've got either 3 or 4 arguments, 2 or 3 arguments we're passing to false, passing to if. And so if is going to assemble that into a proper normal kind of function itself. And what it's doing is is something slightly different to a normal function because we've got this kind of positional aspect to the two things. It's got the a then and an else branch to it, which means you can only actually do one thing. If you wanted to do multiple things, then you can actually wrap it in a do. So, for example, if you wanted to print out a log command of something, and then do an action, and then call a function, then this would be the way you can do it. And you can have like multiple expressions and forms within the do. But here we're only having two do's. So this is the this is the true branch, and this is the false branch, and you can't have any more. So if you wanted to do it still kind of follows the structure of the if. We're having a conditional, then a then branch and an else branch, but you can kind of in each branch you can kind of add more forms. Okay, right, thank you. Yeah, there we go. And then we've had when. Is there anything interesting about when? Oh, then we got nil itself. So we talked about this truthiness and equality in Boolean. There's a lot of things. There's a lot of examples there. I'll put them in. I think I've got some of those as references in the book as well. This is the equals is a little bit different in, or simpler even, in Clojure than most languages, because it's not an assignment, it's an equality. So in some languages you have, let's see, you'd have, let's jump to the bottom of this file. You have x equals, I don't even know where equals is. I use it that way. I have x equals 3. That's not how we do that. You would do, that's assignment, and in Clojure you do def for assignment. So you're defining the value that is represented by x, which is a really bad name. So please don't use x in your name unless you're doing perhaps noughts and crosses. That would be potentially appropriate. And so yeah, so we've def, and then so that's the name we're going to represent the value by, and we might want to do like the string of x to represent the x player, and so we can call it whatever name we want to, and that's how we do an assignment. So that means we're freeing up the equals to be for equality, and so that simplifies this function. So equals again is another function that we call, so we put it in the start of the list, and then we can do 1 equals 1 equals 1 equals 1 equals 1 equals 1 equals 1. So again, we can have multiple arguments and all passing to 1. If we passed in true, I'm sure you've worked out what happens there. There we go. And so we're not constrained by the equality. We can basically pass in a whole chain of things and see if they're comparable, and we can do even pass in functions. Let's do, oh yeah, we can do wrap. That's is that right? Am I adding up correctly? Yes, there we go. So any kind of expression that's returning a value here we can include, and we can also use that for true and false as well. So we might want to have some conditional. So we'd kind of use this with inside things like an if or a when statement. So we could do if that, then we could do true. And you can do more interesting things than just return true and false. We can do, oh yeah, we can do false. There we go. So yeah, so we can use equals for equality there, like we did here. So this is true, and if we put in something else like 3, 2, then obviously we're going down the last branch for that. And we can do equals true, true. Obviously those equal the same. If you've got true and false, that's not going to be equal. Oh, false. And same for nil. That's also false, because here nil is again is acting as a falsy value. And then we've got nil, true, and if we do 1, that's false, because again it's not the same. It's comparing values rather than comparing the properties of the values. So that's false. But if we have a function equals 1, then the result of this function is a true value, then comparable. And you can also compare not just simple values, but also collections or sequences. So if you've got, let's see, 1, 2, 3, and 1, 2, 3, then they're both true because they've got the same values. The interesting thing is when you, if we do a comma refactor cycle and just change that to a list, and then we just need to escape the list. So the one thing we didn't mention when we talked about calling functions was using the quote function. So if I want to just treat a list as data instead of the function call, then I can put a little quote mark in front of it, and this is the same as doing quotes 1, 2, 3. Oops, no, that's not right. 1, 2, 3. There we go. Oops, sorry, I pressed the wrong button there. There you go. So that's basically returning the value of the list as a value in itself. Whereas if we do 1, 2, 3 without a quote, then it's going to try and execute. It's going to try and call 1 as a function. So what we got here are 2 sets of values, 2 collections, 2 sequences, and we're comparing to see if they're the same. So like a vector and a list are different conceptually. So would these be true or false? That's the interesting question. And they're true. So they are equal because the values within inside those collections, those sequences, are the same. If we change that to 4, then they're now false because the values, their intrinsic values are different. So therefore they're no longer true. So often you will get the result of a function call will be a list, a sequence, and that will be, and some people concern themselves about changing that back to a vector, a square brackets. but most of the time you don't need to, unless you explicitly need to define something in a vector. Then if the values are, if you're only concerned about the values, then it actually doesn't matter if it's a vector or a sequence. It's there really, it only kind of concerns like the performance of accessing those. So a vector is indexed, so you can do random access. So that's a lot faster if you just wanted a particular value at the end or in the middle somewhere of a really long data structure. And a list is always going to be consumed sequentially, so it's going to start at the beginning and go through each one. So if you've got a very long list or a very long sequence of values, then using an indexed data structure is more efficient. But when you're just comparing the values, it doesn't really matter. Any questions? Oh no, we've gone quiet. Maybe I've talked about conditionals too much. Let's see what else we've got to talk about in the book. Well, I've lost the book. I've lost my screen. So many screens. There we go. So I think we've covered those. Oh, yeah, we've done ors as well. I think one thing I didn't mention about OR is that, like, yeah, so it can be useful because as soon as you hit like a truthy thing, then it stops. So you could actually throw in an error condition in here, or a call to an error, a throw, and that would only be called if it didn't find any expressions. So I think I've got that in one of the exorcism guides. I think it's yeah, RNA transcript. If we go and have a look at the source of that, I think let's make that a little bit bigger. Yeah, so I'm using an OR here to basically convert between DNA to RNA. And so if it's a G, then I want a C. If it's a C, I want a G, and so on and so on. So long as I'm passing, I'm passing a string here, and I'm mapping over it, so I get each of the characters in turn are passed to this DNA to nucleotide, so DNA to RNA converter. And if I'm passed a value that isn't there, this is going to return nil, because when you do a map lookup and you don't find a matching key, then it's going to return nil. So this first part of the OR is going to fail essentially. So therefore it will throw an exception. Now this is kind of stopping your program or throwing up something really nasty. So you only want to do that if something else doesn't happen. So putting an OR around it then just makes sure that it's only thrown when necessary. So this is a nice usage of the OR expression here. So long as we get good data coming in, we're going to convert it. If we get bad data, then we throw up a little message saying that. So we could handle it somewhere else or just stop the processing, however we want to approach that. And it's just a nice simple way to put some conditional in there without doing anything. And it means that we don't have to process the string of data separately. We don't have to kind of process the data separately to look for incorrect data. We can actually do that as we're going through by just trying to process the data, and if we get a nil returned, that's a falsy value, and so then we can throw in the assertion because we got a falsy value. So it's a nice efficient way to process the data. Oh, there we go, true and false. No, I've covered that already. There we go. So we did. So that's kind of. Is there anything else? Yeah, in terms of just actually the really basics, just throwing around data and values. We're calling functions. We can work with values. Values can be simple, like a 1 or a string, or they could be a collection of values like a vector or a list. And then we can do some kind of simple conditional checking. And if we want to bind something, so the example I think I used was just binding x player to the character, to the string x. And when you're defing something, that means you don't have to type it out again, because you can just use the name to represent something. So the more involved the bit of data is, or the more times you use that bit of data, then the more kind of need there is for using def. And def is a kind of global value in that it's shared between kind of all the functions in the namespace. So we organize Clojure by namespaces, which are related to the file names. So this is a namespace of Practicalli getting started, and the file name is getting started in the Practicalli directory. So the namespaces line up to the file names. It just makes it makes it easier for all the tools to find the right files, and then you can specify context of your functions that you define and the values you define a lot easier, because it's all within the context of a particular namespace. So if we def something here, or should we? Where's my other def? Def. There it is. Boom. GD. So we can define something here. There we go. Def player, and then we might have a function defn player turn that takes a value called player, and then does something with that, and we might have another function that's called winner that takes in the game board. Does a bunch of stuff, and then it prompts out the winner, like string is player x player. So you can use player as a name that's available for any of the functions inside this namespace. You can even access it outside if you really wanted to, by including the namespace in a different namespace. But essentially, it's a value, or it's a name for a value we can use throughout multiple functions. What does the book say? Yeah, so then we can use the name. If we evaluated just the name, we actually get the value back for it as well, and then we can also use it with inside functions. So here we're defining severity mild. Oh god, it's a disaster. We're on fire. Okay, yes. And so here, I don't really like using defs inside expressions. I think that's not a good example to follow, because defs should be global. So this is one thing I'd kind of dissuade you from doing. You can do that. So if we were going to do this, I'd do this as a let. Let's do that as a let. So what they're doing, def error message. I don't really understand what they're doing here. Oh, they're updating. No, I don't really like this at all, actually. Why are they doing a def inside there? That's very strange. I must have missed something, surely. Oh, okay. So you might be tempted to do something similar in Clojure. Oh, right. It's comparing it. Okay, right. Comparing it to Ruby. Okay, so it is saying don't do that. Yes, I should read the book, really. Yeah, so here we go. We're actually defining a function that does that, that takes the severity in. And if the severity is mild, so here we're using the argument as part of the conditional test that we're doing. So we're checking to see if it's mild. If it is, then yeah, mildly inconvenient issue. Otherwise, we're doomed. And then it's returning the value of the if to be joined onto the end of the string that we've got there. Yes, so it does suggest not doing this. There's nothing to stop you in Clojure doing this, but there is the let function, which is much more preferred to do that approach. I'm sure they covered let in here. Let's have a look for let. There we go. That's not the let I was looking for. Actually, let is also a... Oh yeah, so that's covered in part of the... I think that's covered in the functions, maybe. I don't know. There's a lot of lets because it's a common English word. Oh, actually, tell you what. Will it work with this? There we go. Oh, sorry, I'm a bit wheezy. That's better. So yeah, there is some lets. So if you wanted to do a if you wanted to define a name local to a function, then we'd use the let function instead. That's not a very good example. It's more complex. But you can also do kind of a let by itself as well. You want to let. Actually, let's just take this. Let's take that example and write it as a let. Sometimes a let is a simple way of writing a function too. Excuse me for the scrolling quite quickly. No, I think we're yeah, there we go. What was that horrible thing I saw? Oh, there we go. I've lost where I was now, sorry. I'll get there eventually. I think I did warn you that this was live and unscripted, so... This is quite a long chapter, so we're not going to cover everything, but what we don't cover this week, I'll cover... Oh yeah, it's before the... It's just before here, isn't it? So I might kind of leave it like the strings and numbers, the data structures. Yeah, there we go. I might leave the data structures for the next week, or maybe even do it on Sunday if I'm feeling better. Okay, there we go. So we do, rather than creating a function, was one of the valuable things I found when starting Clojure was to do a little let binding to help me kind of figure things out before I create the function. Let's do that. Oh, that's there, isn't it? There we go. Get rid of that. So we could do let and so the let form is a list with the let at the start, because that's a function call, and then we basically put in like pairs of inside a vector. So we got like the name that we want, and then the value, and then we can do something with the name, and Yeah, so that's kind of the generic form. So we do like this. We do. Let's just change this to. Up, no. Practicalli. Yeah, that'll work. There we go. It's the string practically. So we can use that. Obviously, this is a terrible example because this is far too overkill because we're defining the name and then just using it once. Obviously, we just use string practically. But if we had several expressions, or if we're using the name, using company name in multiple places, then this saves us having to kind of define that, reuse the data. And when it comes to refactoring, then you'll just change the value once that's bound to the company name, and you can see what else it does. So if I change this to rocket, oops, can't type, there we go. Then obviously it's changed already, and I've realized I made a spelling mistake, so I had to change it to that, and then I download that. So it allows me to, change this value over and over again as I'm kind of developing the algorithm for the problem I'm trying to solve. And it's a very handy way to just kind of work out a specific algorithm and then put that into a function. Because once you've defined a function, then you actually then have to go and call it. So if I wanted to, if I define winner, which is got a bug in it. Oh yes, I'm not passing in X player, am I? Which I should do. X player. And I haven't defined Y player, so I really should put Y player in there as well. Let's do Y player. Because if we're passing all the arguments that the function needs, there you go. Then that's a better approach, because we're not. Although we can use these defs as shared states, we should really pass them into the functions that we're actually using them into. So like here in player turn, we're passing in player, so we would call this with player turn. Didn't evaluate that, did I? I should. Once you evaluate it, then my autocomplete is going to kick in. There we go. Whee. And so we can pass in. Oops, I didn't do. I should do Y player. Player. I didn't change that to Y, did I? No. There we go. Yeah. So if we're using a function, then we need to call it. That's not going to do much. That might do a little bit more. Actually, it should be. Let's call it players. There we go. Designing on the fly here. There we go. Oops, no, that's not right. Let's wrap that. As we pass in here, winner. So I've had to kind of do quite a few things here just to get the shape of the function right that I want. So that's kind of a bit of design that's involved in there. Although obviously that could evolve as I'm like trying to identify what winner should do. And then we've got the game state. We've got like a map probably that we're passing in with score, which is probably like a vector or a map or something. And then we've got maybe a vector of players. So we got X player. I didn't evaluate those. Player Y player. There we go. But if we're just doing a let, then I don't have to do that. Even though it's slightly simple, it's very simple ceremony. It means I don't even have to do that. I can kind of work out what the algorithm is without kind of defining a function. And so that means if I'm defining a function, I do have to evaluate any changes in the function and then go and call that function to see what it is. And so then, yeah, so there's a bit more round tripping when you're doing this. Or the advantage is you do have a function at the end. But then you can also take this let and put it into and just wrap it with the function that you need, and then see if you still need the let. If you've only got one thing, that might just be your argument. If you've got multiple things, then obviously you might want to keep the let, and yeah, your algorithms, all your expressions here are going to be the same. You just wrap the whole thing. You take that thing and put it in a defen. Oops, didn't want to do it. Defen. Oh, and give it a name. Yeah, and an argument. Decide what the argument you want to pass, and then you pass the let in there as well, and then you've got your pretty much your function that you've defined by designing it in the let first, and then popping it into a function. So then you can call it and call it in several places throughout the namespace. I hope that makes sense. How are we doing for time? Oh my god, we're way over time. That's probably why the questions have stopped. So what have we covered? We have covered simple function. Oh, we covered functions, defining simple functions, defining doing the assignment using def, so assigning names to values. We've done functions, just the basics of functions. So we've got a function here using defen. So just like def defines a value, defen is defining the function that we're doing. So we give it a name, hopefully a meaningful name. We define what the argument is in this vector. Yeah, I could do this for hours. And then we have the body of the function that actually does things. It's like, this is where your algorithm is, your business logic, whatever you want to refer to it as, and that can use a let binding in there. So if you want to have some local names that are just specific to the function, then you have the let statement, and therefore this minimizes redundancy. Also, you can use kind of like, once you defined this name, you can use that name straight away. You can even use that name in the next let as well. So yeah, and so you can use not just simple values but also functions, because functions always return a value. So I can use string. That's the company name is awesome. And hopefully, yeah, so now do that, and my algorithm is a terrible name. There you go, my algorithm. Oh yeah, okay, yeah. So and then instead of company name, we're just doing. This isn't a particularly useful example. Sorry. There we go. I am awesome and waffly. Well, I'm certainly waffly. I'll let you decide on the other one. Yeah, so a let is really, really useful. I do encourage you, if you're not using let that much, then to use it. can reduce a lot of redundancy in your code, and it's a really nice way to have some values to play around with as you're experimenting with an algorithm that you're trying to develop. As you're experimenting with expressions and putting them together, just put a little letter around it, and you can like weave through little values for it, and then go off and change this to a different value, see how the rest of the code works. And you can just evaluate it once and you get the result. So you can evaluate it, change the data, evaluate again. So there's a little bit less on the tiny amount of ceremony you have defining functions. There's a little bit less ceremony using let, so it's a little bit of a shortcut. I hope that makes sense. Okay, I go back to the book. So that's the first bit covered. I thought we'd cover more of it than that, but I think we covered some really useful things there, and hopefully you found that useful. So we'll have a look at data structures, and I'm feeling a bit better now, actually. Yeah, maybe I should have a warm-up broadcast before the real broadcast. But I think there's a lot of this stuff is kind of repeating it, but with different kind of examples of kind of more meaty, kind of interesting values, and using maps and lists. So it's good to kind of have a look at it as well. So we'll kind of do another broadcast on that and cover those in more detail. And this might end up being 2 or 3 broadcasts. Just a reminder, there's also there's a really quick reference as well. If you want to go deeper than this, what we've covered already, if you want a refresher about Clojure as well, there's a really nice, it's called, what are you doing? Let's go back to there. It's a really nice video series. It was done quite a while ago. But it's this Brian Wills video series, and there's only about, I think there's about 10. I think he updated it a few years ago, but if you want to kind of really kind of understand kind of the different parts of Clojure and how it works underneath, there's some really nice things there. I've learned quite a lot from there, and I think they're still very relevant in that respect. If you're still just learning the basics, then there's some, like, just a few basic kind of examples of the core functions there that we're using. We did cover on some of those again today, and I think in section 4 and 5 we'll cover more of these. And then kind of learning how to model data as well, that's all coming along. But this page is just a very quick way of just seeing just a handful of examples to get you going, and to see things there. Ooh, empty. Seek. There we go. Yeah, signal. There we go. Cool. And seek. So again, that's returning a value. So that's essentially true. Okay, I'm going to stop pontificating and let you go. Thank you very much for listening. I hope you found this useful, and we'll see you again next time. Hopefully this horrible flu I've had will be completely gone by then, and I might even comb my hair as well. Okay, thanks again, and see you next time. Goodbye.